Hey, let me ask you something. What in the world does a rusty nail have in common with your smartphone? It kind of sounds like the start of a bad joke, right? But the answer is this incredible chemical process that's happening all around us all the time. Today, we're diving into oxidation and reduction, what I like to call the electron dance that literally powers our world.
I mean, seriously, think about it for a second. One is a symbol of something just slowly falling apart. The other is the absolute heart of our super fast-paced digital lives. But the answer, and it's a surprising one, points to one of the most fundamental processes in all of chemistry.
So here's the big secret. The connection between rust and your phone's battery, it all comes down to one thing, an invisible transfer of these teeny tiny particles called electrons. It's the exact same process, just happening at totally different speeds. One releases energy super slowly as heat, the other does it really fast, giving you electricity.
Now, this whole process has an official name, a redox reaction. The easiest way to think about it is like an electron dance, okay? One partner gives away electrons and the other one happily accepts them. And this simple little exchange, it's the engine driving, well, almost everything, from how our bodies get energy to how a fire burns.
Okay, so if it's a dance, you know it's got to have some signature moves. And in our electron dance, there are two key steps that are always, and I mean always, perfectly in sync. You literally cannot have one without the other.
On one side of the dance floor, we've got oxidation, and that's just the loss of electrons. And on the other side, we have reduction, which is, you guessed it, the gain of electrons. They are perfect opposites, two sides of the very same chemical coin. Anytime one substance loses an electron, another one has to be right there to gain it.
Now, I know trying to keep oxidation as loss and reduction as gain straight can be a little tricky, but chemists have a fantastic little trick for this. If you only remember one thing from this whole explainer, make it this mnemonic: oil rig. Just say it with me: oil rig. Oxidation is loss, reduction is gain. This simple phrase is going to be your key to understanding all of this. It's a lifesaver, trust me.
So, enough with the theory, right? Let's actually see this electron dance happen. Here we've got a really straightforward reaction. We have solid calcium reacting with solid sulfur, and they come together to make calcium sulfide. On the surface, it looks pretty simple, but underneath, those electrons are on the move. So first up, the calcium atom. It gives away two of its electrons. Now what's our mnemonic? Oil rig. Oxidation is lost. So, because calcium lost electrons, we say it's been oxidized. And check this out. See how the equation shows it ends up with a positive charge? That's because it just gave away two negatively charged electrons. Makes sense, right?
Okay, so where did those two electrons go? They didn't just vanish into thin air. Nope, they were immediately scooped up by the sulfur atom. Sulfur gains those two electrons, and since reduction is gain, thank you oil rig, the sulfur is being reduced. And there you have it. The dance is complete. Calcium loses, sulfur gains. Perfect partnership.
All right, that last example was pretty clean, pretty easy to see, but let's be real. In more complicated reactions with a bunch of different atoms, it's not always so obvious who's losing and who's gaining. So, to track the dance moves, chemists came up with a kind of score-keeping system, and it's called oxidation numbers. Yeah, you can really just think of an oxidation number as a score for each atom that helps us follow the electrons. It's super handy. If an atom's score goes up during a reaction, it got oxidized. If its score goes down, it got reduced. Simple as that. So how do we figure out these scores? Well, what's cool is it's kind of like a little puzzle. There are a few rules, and one of the big ones is that oxygen almost always has a score of -2. Now, in a neutral molecule like carbon dioxide, the total score for the whole thing has to add up to 0. So, if we have two oxygens, each with a score of -2, that's a total of -4. For the whole molecule to be 0, what does carbon's score have to be? You got it. +4. See, it's just a little bit of logic. Okay, so now that we know how to keep score, we can start to define the actual roles that these different substances play in the electron dance. You've got your givers and you've got your takers, but they have some names that can be a little bit tricky at first. All right, stick with me here, because this can feel a little backwards. The substance that gives away the electrons, the one that gets oxidized, right, is called the reducing agent. Now, why is that? Because it causes the other substance to be reduced. And on the flip side, the electron taker, the one that gets reduced, is called the oxidizing agent, because it causes the other guy to be oxidized.
Let's look at another quick example to lock this in. When zinc metal reacts with chlorine gas, the zinc atom is the one that loses electrons, so it gets oxidized. That makes zinc the reducing agent. The chlorine molecules gain those electrons, so they get reduced, which makes chlorine the oxidizing agent. See? The giver is the reducing agent, the taker is the oxidizing agent. You'll get the hang of it.
All right, it's time to put all of our new tools to the test. We've got oxidation, reduction, our trusty friend oil rig, and these agent roles. Let's use them all on a really fascinating real-world example, the chemistry that made old-fashioned photography even possible. This is going to be fun. So, in old-school black and white photography, light hitting the film triggers the breakdown of a compound called silver bromide. Let's walk through this using our new skills step by step. First, let's assign the oxidation numbers. In silver bromide, silver has a score of +1 and bromine is -1. Easy enough. Next, let's spot the oxidation. Bromine's score goes from -1 up to 0. That means it lost an electron. And what do we know? Oxidation is loss. Now for the reduction. Silver's score goes from +1 down to 0. It gained an electron. Reduction is gain. And finally, let's name our agents. The silver ion took the electron, so it's the oxidizing agent. The bromide ion gave the electron, so it's the reducing agent. And here is the absolute magic. This invisible little electron transfer creates tiny solid particles of pure silver. And millions of these particles are what actually formed the black and white image on the film. That's chemistry you can literally see.
You know, this electron dance is happening everywhere. It's happening inside you, right now, in the process called respiration that gives you energy. It's happening in a car engine. It's happening in the battery that's powering whatever device you're watching this on. This dance truly, truly powers our world. So the only real question left is, where are you going to spot it next?